This is GCSE Further Maths Pure. We're on Chapter 5, Differentiation, and we're looking at a curve sketching. So last time we sketched a quadratic. Here we're going to try and sketch a cubic. So again, just follow the same three steps. Number one, where does it cross the y-axis? So crosses y-axis when x equals 0. So that was, in this particular case, y is 0 cubed minus 4 upon 0 squared plus 4 upon 0. So that's an easy one. It crosses in at 0, 0. So that's going to be through the origin. Part 2, where does it cross the x axis? And we put y equal to 0. So we will have then x cubed minus 4x squared plus 4x equals 0. And this is a special type of cubic that we need to solve. So we can take an x out of this and then we'll do the quadratic separately. So it's x squared minus 4x minus 4 equals 0. So that means that x is 0, or x squared minus 4x minus 4 equals 0. Factorizing this then, x minus 2 upon x minus 2, which is actually a repeated factor, which is a kind of a strange one as well, but that's okay. And that means that x minus 2 equals 0, or x minus 2 equals 0, and sure enough, then that gives us x equals 2, or x equals 2. So our 2 points then are going to be 0, 0, and 2, 0. So that's quite strange for a cubic equation, but that's okay. We can deal with that whenever we have it. Alright, the fact it's a repeated factor actually means it doesn't cross, but it just touches the x-axis, but that will hopefully become clear as we go a bit further. So for part 3 then we're going to try and find our turning points. So we're going to find dy by dx, and dy by dx then in this case is going to be 3x squared minus 3x squared minus 8x, isn't that right, plus 4. So at our turning point, dy by dx equals 0. Just give me a second. So putting this equal to 0 then, we have 3x squared minus 8x plus 4 equals 0. And we're going to factorize this then to get our turning points. Space might be an issue here, but we'll be okay. 3x there and an x there. And how we're going to negotiate our 2. So we're going to go for 2 and a 2. That's going to give us a 6. That's going to give us a 2, which is going to give us then our minus 8. So 3x minus 2 and x minus 2. So that means 3x minus 2 equals 0, or x minus 2 equals 0. It gives us x is 2/3, or x is 2. Okay, to find the y coordinates, we substitute this into y equals x cubed minus 4x squared plus 4x. So in this one, it's going to be y equals, in this case here, over here, 2/3 cubed minus 4 upon 2/3 squared plus 4 upon 2/3. That gives us, again, you can trust me, it's 1 5/27. You put it into your calculator. For this one here, we're subbing in the number 2, a bit more straightforward. Y equals 2 cubed minus 4 upon 2 squared plus 4 upon 2. And that gives us 0. So our coordinates then are going to be, turning points are 2/3, 1 5/27, and then 2, 0, which he suspected then was going to happen. We have to find if they are maximums or minimums. So find nature using d2y by d x squared. So differentiating this gives me 6x minus 8. X minus 8. So that's where we're going to put this. Now let's put it over here. So at x equals 2/3, d2y by dx squared equals 6 upon 2/3 minus 8. 6 times 2/3 minus 8. So 2/3 of 6 is 4. So take away 8. Doesn't really matter what it is, but it's less than 0. Less than 0. Therefore, it is a maximum. That x equals 2. d2y by dx squared equals 6 upon 2 minus 8. That is greater than 0. Therefore, it's a minimum. So what do we have? We have down here, so we'll do some sort of sketch. We have it crossing at 0, 0. We have it touching at 2, 0. And we have our turning point here at 2, 0. So it's either going like that, but it says that at 2 it's a minimum. So it must be going like that. And our other turning point is at 1 5/27. And then, sorry, 1 5/27. What's our y coordinate? 2/3. So 2/3 here. And 1 5/27. So that's going to be 1 5/27. And that then is going to be our 2/3. So our best possible sketch here. Let's see how we go. It's going to go up like this. And then turn down and come round. And go up then like that. I would like a kind of a nicer curve there. But other than that, then it was fine.